In this episode, we look at Unit 4, Rocks, Minerals, and Soils. That's page 27 from our science workbook. The ground we walk on, build on, and grow gardens on is made of rocks. Rocks are solid, non-living materials formed from the Earth's crust. All rocks are made from minerals, pebbles, soil, and fossils. Fossils are the remains of dead plants and animals. Rocks have different colors, shapes, and textures. A geologist is a scientist who studies the composition of rocks, minerals, and soils. How are rocks formed? Rocks differ from one another as they are made in different ways. There are three main types of rocks that make up the Earth's crust: igneous, sedimentary, and metamorphic rocks. Igneous rocks. When a candle burns, a runny wax is formed that trickles down its side and solidifies. That is, to become solid. Igneous rocks are formed in a similar way. Igneous rocks are formed when molten magma cools and hardens inside the earth or when lava cools on the surface. Molten rock material that has reached the surface of the earth is called lava. As lava cools, it hardens. This hardened rock can build a mountain called a volcano. When a volcano erupts, it explodes. Lava, rocks, and ash burst out of the volcano. Because of the heat needed to form igneous rocks, they are sometimes called rocks of fire. Granite is the most common form of igneous rock. Basalt, obsidian, and pumice are other kinds of igneous rocks. Most of the Earth's crust is made of igneous rocks. Here we have the diagrams at the bottom: basalt, granite, and obsidian. We turn now from page 27 to page 28. Sedimentary rocks. You never know what you might find in a sedimentary rock. Many rocks of this type are made up of lots of other rocks or even small animal remains, all cemented together. Sedimentary rocks are built up from particles laid down as layers. They are usually soft and pale in color. Wind and water break rocks into small pieces which settle at the bottom of rivers, seas, or oceans. These layers of sediments harden to form sedimentary rocks. Shale, sandstone, conglomerate, chalk, limestone, and rock salt are all examples of sedimentary rocks. Here we have diagrams: shale, sandstone, and limestone. Now we move on to metamorphic rocks. When you bake bread, you mix flour, yeast, and water together and bake it in a hot oven. In a similar way, heat and pressure from the overlying rocks may change the nature of the rocks below. This process is called metamorphosis, which means change. Metamorphic rocks are rocks that have been changed from some previously existing rocks. A combination of heat, chemical action, and pressure changes igneous rocks and sedimentary rocks into metamorphic rocks. The appearance of metamorphic rocks varies depending on the type of rocks from which each is formed. A familiar metamorphic rock is marble, which was once limestone. Heat melts the limestone. The melted limestone hardens and takes on a new crystal form called marble. Slate is formed from shale. Sandstone changes into quartzite, and granite changes into gneiss, pronounced nice. Note: an important mineral found in sedimentary and metamorphic rocks, but not in igneous rocks, is calcite. So here we have some rocks at the bottom. We have quartzite, gneiss, marble, and slate. We now move to page 29, where we will examine the rock cycle. Starting at the top, we have igneous rocks. Then they can be eroded. So we have erosion. The sediments then become sedimentary rocks. Sedimentary rocks, based on heat and pressure, can change into metamorphic rocks. Going anti-clockwise now, igneous rocks can change based on heat and pressure. Some common rock types and their uses. Rocks and the uses. Granite, used for building blocks, road, stone, and countertops. Marble, used for building blocks, flooring, and monuments. Sandstone, used in the building industry. Slate, used for roof and tiles. We have limestone, which is used in building blocks and cement, and rock salt, which goes on to make table salt. We move now to minerals. Minerals are non-living solid matter from the earth that may have a specific shape. Gold and diamond are examples of minerals. Minerals have different physical properties. They can be any color or texture, shiny or dull, and soft or hard. What's color? Color is the most obvious physical property of minerals. Luster is the appearance of the surface in reflected light. Hardness is the resistance a mineral offers to scratching. Transparency is the degree to which minerals will transmit light. A mineral is given a number from 1 to 10 for its hardness. Talc is the softest mineral and has a hardness of 1. It is grounded up to make talcum powder. Talcum powder can be found in baby powder. On to page 30 now. Diamonds are the hardest minerals and have a hardness of 10. They are used on the cutting edges of some saws and drills. Some minerals are valuable for their beauty, for example, gold, diamond, and silver. Quartz is a transparent mineral used in the making of sandpaper and glass. So here we have examples now. We have diamond, talc, gold, and quartz. Gypsum and bauxite are examples of minerals found in Jamaica. Soils. Soil is a natural resource. When a rock breaks apart, its minerals become part of the soil. Soil is not only made of rocks, it also has air, water, and matter. Many different types of soils exist. They vary from one place to another, depending mainly on the underlying rock. Soils have different colors. When plants and animals die, they decay or rot. The decayed matter is called humus, which becomes part of the soil. Humus gives soil a dark color and also provides nutrients, which is the substance that plants and animals need to live and grow. We go on now to types of soils. There are 3 main types of soils. How many? 3 main types. They are clay, sand, and loam. The type of soil and the substances it contains are very important to agriculture and therefore to our lives. Clay soil is heavy and does not allow water to drain through it easily. It is sticky when wet. Clay soil feels smooth. It contains many nutrients which allow plants to grow well. Sandy soil is loose and easy to dig. Plants do not grow well in sandy soil because it has few nutrients. It is light and water drains through it easily. Loam or garden soil is a mixture of clay, sand, and humus. Many plants grow well in this soil. It holds water and has many nutrients for plants. We turn now from page 30 to page 31. Weathering, erosion, and soil conservation. When rocks wear down or break apart into smaller pieces by chemical and the elements of weather such as wind, water, and temperature, the process is known as weathering. Plants and gases in the air can also cause rocks to weather. Weathering changes igneous and other rocks into sediments. Erosion is the removal of topsoil and rocks by wind or water. Soil erosion can be caused by deforestation, poor farming, or overgrazing. Soil conservation. Because soil is so important to our lives, you think people would take care of it, but they have not always. The proper care of soil is called soil conservation. Sometimes people have made mistakes that cause the soil to erode. These mistakes can be avoided by using the following methods. 1. Rotating crops. That is planting a different crop each year. Terracing. The leveling of hilly areas so that a series of steps can be formed on a slope to prevent erosion. 3. Planting suitable crops for the soil and sometimes plowing. 4. Not allowing animals to graze one area until it is barren before they are moved to another. This is called overgrazing. 5. Planting trees on slopes where soil is eroded. Now this brings us to the end of our unit in this episode. Please make sure that you do your unit review on page 31, beginning on page 31, and going all the way around to page 34. In the next episode, we look at weather and climate. See you then.